Hi guys! Welcome back again to our video lecture for this week. I hope hindi po kayo magsawang makinig sa ating mga video lectures. Pagtiyagaan niyo na. Okay, now if you want this video lectures na meron siyang, alam niyo yung parang may video recording din siya dito sa upper right corner. If you want na meron siyang ganon, just let me know. Okay, and we'll see if pwede natin gawin. Kasi baka mamaya maboard kayo listen lang So anyways, let's proceed. Now, by the way, last chapter we talked about, or last week we talked about the voltage and the current laws. And then we partially discussed about those laws, but then meron pa po siyang continuation, hindi pa siya tapos. And so this week we are going to continue discussing it. Okay, but before we continue, let us have first a review. Okay, so last week, na-introduce ko tong circuit na to, deep mo ba? So I used this schematic diagram to present to you the concept of node, of path, of loop, and branches. All right? So I hope you could still remember. Okay, pag sinabi nating node again, these are just solder joints in actual world. Tama po ba? And yung node, somehow, medyo nalilito yung students because sometimes maraming nodes na nilalagay but then actually isang node lang naman sila. Like for example, this one. Ito node at saka ito, the same lang to. Ibig sabihin, pwede mo siyang i-combine. Pwede mo siyang isahin na lang, which would look like this. Di po ba? At how do we know na equal yung nodes? Simple lang, kapag yung mga elements nakakonect sa kanilang dalawa are equal, then equal din yung node. For example, this one, ang nakakonect sa kanya is this current source, this resistor, and this resistor. And for this one, we also have the same resistors and this current source. So, the same lang. So, ibig sabihin, the nodes are the same din po. Okay, kapag ka the same, pwede natin siyang i-combine. And based sa ating napag-usapan last week, no, na mas easier siya, anong importance in identifying whether these are just the same node or not? Mas madali pong i-solve yung ating mga circuit if we are able to identify na equal pala yung nodes na yon. Okay? So, I hope klaro yon. And also for the branch, we also talk about branch na pag sinabi nating branch, this is just it just refers to isang element, circuit element at saka node sa ating circuit. Okay, for example, in this certain circuit, meron tayo how many branches we have? 5. Meron ka pong 1, 2, 3, 4, and then 5. Okay? Napag-usapan din po natin yung concept ng loop and path. Okay? So, pag sinabi nating path, ano siya? Parang open lang siya ng loop. Tama po ba? Kasi loop is just a closed path. Kapag ka path, it's just, for example, from this node, we move into the circuit element, into this node again, and from, we go here, and we stop here, that is a path. Okay? But then if we continue na kumbaga kung saan tayo nagsimula, doon tayo natapos, and then that is a loop. Okay? Now the thing with a loop is that loops are path. Okay? Path sila. So, ibig sabihin sa loop, hindi pwedeng merong isang node na paulit-ulit. Kasi for example, I'll start here, travel ako papunta dito. Wait, I'll start here, mag-travel ako papunta dito, dito. Okay? Dito, right here. Punta ako dito. Hindi pa ako mag-stop dyan. Babalik pa ako. And then, ulitin ko naman siyang libutin papunta dito. Okay? Na if you notice sa ginawa kong yon, kung saan ako nagsimula, dun din ako natapos. Diba? That is the definition of loop. But then, however, if you notice, itong node na to, dalawang beses siyang nadaanan. Okay? And then, hindi pwede yan sa loop. Although, ang pinaka-definition naman ng loop is kung saan ka nagsimula, doon ka matatapos. But then, always remember that a loop is a path. So, ibig sabihin, bawal din na may mga nodes na paulit-ulit na nadadaanan. Okay? So, ayun lang naman sa nodes and branches. Okay? So, next is, we have this one. Okay, so remember this. This is the illustration that we use to illustrate the idea of KCL. Okay? So, again, itong mga diniscuss natin last time, yung KVL and KCL, these are laws or techniques na pwede natin gamitin kapag ka nagsasolve tayo. Okay? Again, kapag ka nagsasolve tayo, di ba, sabi sa chapter 1, wait, ano ba yung maingay? Sabi sa chapter 1, It's either you're looking for the current, the voltage, or the power, di ba? Yun lang naman. So, itong mga techniques na to, itong KVL, KCL, Ohm's Law, which is V is equal to IR, these are just the things or techniques na pwede mong. So, next. I know, na-encounter nyo na to sa problems na sinusolve nyo. Okay, there are times wherein merong mga voltage source and power, current sources na madami sila. Okay. See, for example, nakakita kayo ng mga voltage sources na naka-series. Okay. Meron din mga current sources na naka-parallel. So, paano yun? Okay. Na actually, pwede mo naman siyang isolve na as is lang sila without even simplifying it. Pero, mas madali ang buhay kapag sinimplify mo muna sila. Okay. Because magiging simplified yung iyong circuit. E di mas madali siya gawin. Okay. Now, how do you simplify? Simplify. How do you simplify this? So, simple lang. You just have to take the algebraic sum of all the voltages. Okay? Now, say for example, kasi paano, take a look at this ha. Iba-iba kasi notation niya. Itong dalawa, nasa baba si negative, nasa taas si positive. But this one, baliktad siya. Okay? Baliktad siya. So, what will happen? Upon simplifying it to its equivalent na voltage source, mamili ka kung sino yung susundan mo dito. Say for example, napili mo tong una. Okay. Na ganito yung orientation na nasa taas si positive, nasa baba si negative. Edi, lahat ng mga baso, voltage source na ganyan yung orientation, positive yon. So, V1 is positive, of course, kasi siya yung original. V2, same sila ng orientation, and then that's positive. Minus tong baliktad na orientation. Okay po? So again, kapag baliktad naman yung napili mo, say for example, okay mo, mas gusto ko tong nasa taas si negative, nasa baba si positive. Kapag ganun, edi ito na naman yung positive mo. Okay, kasi ito na yung magiging reference mo kumbaga. So yung positive mo na naman si V3 at saka magiging negative si V2 at saka V1. So ang mangyayari, so magdodraw ka ng circuit, figure na ganito, nasa taas si negative, nasa baba si positive, so then you would have V3 minus V1 minus V2. So, ganun yung mangyayari. Okay? So, the same lang sila. Okay, pagdating sa current sources, kapag ka nakaparallel sila, anong mangyayari? Still, ganun pa rin. I-add mo lang sila. Pero mamimili ka kung sino yung iti-take mo as positive. Say, for example, gusto mo na ganito yung direction niya, pataas ng current mo. So, ayun, kukunin mo na yung napili mong direction. So, lahat ng pataas na same sa kanya, positive. Lahat ng hindi same sa kanya o pababa, negative. So, in this case, magiging positive si I1. Negative si I2 kasi pababa siya, hindi siya same direction. Then, positive ulit si I3. Okay? Now, kapag ka napili mo din naman na pababa siya, okay lang din naman yun. But, you have to be uniform. So, kailangan lahat ng pababa, klaro sa'yo na lahat ng pababa is positive. So, ang mangyayari, so ikakopy mo tong symbol mo ng current source na pababa yung direction. So, ang mangyayari, yung I1 mo is magiging negative. Tama po ba? Okay, kasi lahat ng pababa, negative, positive na. Lahat ng pataas, magiging negative. So, magiging I1, negative I1 plus I2 minus I3. So, the same pa din naman yun. So, kung makakita nyo, mag-iiba lang yung sign nila, pero lahat ng mga magkakatulad ng sign, same pa rin kapag iba yung pinili mo. Okay? So, ganun yung voltage source. Ganun lang siya. Alright. So, next. So, you have your examples of circuits with multiple sources. Okay? So, merong mga sources dito, example na marami siyang source. Merong iba daw, illegal lest they violate the Kirchhoff's law. Okay? Now, take a look at this circuit. Meron kang negative 5 volts plus 10 volts. And then, wala na. Okay? So, nangyari dito, meron ka lang meron ka lang, say for example, battery. Kinonect mo siyang ganito. Okay? Na pag kinonect mo yung battery na ganun, ano makuha mo? Wala, 'di ba? Wala kang load, sinong gagamit dun sa voltage supply mo? Eh, ba't mo pa kinonect? Okay, so, um, kung iisipin mo, something is wrong. Tama po ba? Okay. But, theoretically din naman, napoprove siya na wrong din siya. Kasi, say for example, maglo-loop ako. Okay? Paano nga yung KVL? Isa-sum ko lahat ng voltage na madadaanan ko sa loop. Okay? Kung ano yung terminal na mapapasukan ko, yun yung susundin ko na sign. So, meron tayong negative 5 plus 10 is equal to 0. Question, is negative 5 plus 10 is equal to 0? No. So, it would make sense. Okay, mali talaga yung circuit na ganito. And if you notice, somehow, they could be connected as parallel, di ba? Parang nakaparallel din tong dalawa. And take note, kapag ka-parallel, dapat same voltage nila. If you notice, 5 volts, 10 volts, the same ba yun? So, mali talaga. Something is wrong. Okay? This circuit doesn't make sense. Eto, tingnan natin. So, meron kang dalawang voltage supply. So, although meron ka ng dalawang voltage supply, hindi magkapareha, pero meron kang load. Okay? So, somehow itong load would balance out everything. So, pag nag-KVL ka, wala namang problema. Hanapin natin yung voltage ng R. Try natin. So, pag nag-KVL tayo, starting here, so papasok tayo sa negative terminal, so we have negative 2. So, negative 2 plus, say for example, VR to, plus VR plus 14 volts is equal to 0. So, on equation 1 unknown, you would have VR which is equal to negative 12. Okay? So, which should make sense. Say for example, meron kang negative 12 dito. Okay, i-check natin. So, loop ulit. So, meron kang negative 2 plus negative 12, that's negative 14. Plus 14, that's equal to 0. Okay? So, pumunta lang sa kanya yung difference ng dalawa. So, okay lang tong circuit na to. This one is wrong. This one naman, if you notice, parang, kasi these are current sources, yung direction niya pa ganun. Okay? Anong nangyari dito? Bakit mali? If you notice, yung current mo, magtatagpo sila. Okay? And actually, pwede naman ganun, meron naman. Pero in this case kasi, take a look at this node. Itong node na to, ha? Etong current na to, pagdating sa node na to, papasok siya, entering siya sa node. Okay, itong current na to, still pupunta siya dito through your resistor. Pagdating sa node na to, papasok din siya. Eh di ba according to KCL, pag may pumapasok, hindi pwedeng papasok lahat, hindi pwedeng palabas lahat. Kung yung isa papasok, kailangan yung isa palabas. Okay? So, eto, mali to. Maliban na lang kung may ibang node na nakakonect dito, pwede naman ganito yung orientation. Hindi ko sinasabi ha, na lahat ng back-to-back na current source mali. Hindi. In this case lang, kasi pagdating sa node na to or sa node na to, lahat entering. Bawal yun. Pero say for example, may nakakonect dito na ibang node, may resistor din dyan, pwede naman. Okay? Kasi malay mo, papasok tong dalawa, palabas naman dun sa kabila. So, pwede yun. But in this case, bawal po talaga siya. So, kagaya nito. Okay? If you notice, parehas sila ng direction, papasok sila. According naman sa KCL natin, if you look at this node, according to KCL, kung papasok to papasok, somehow, you would have an idea na malamang itong dito, yung current is, dito yung direction. Papunta sa resistor. Palabas. Okay? Which is tama naman. At kapag dito natin siya tinignan sa node na to, yung current dito, palabas. Palabas. Okay, palabas silang dalawa. So, if you notice yung current natin dito kanina, di ba, papunta dito. Diretso yung current papunta sa node na to. If you notice, papasok. Okay? So, may lumalabas, meron din namang pumapasok. Okay, so if you notice yung current na, yung current natin or yung electron flow natin is parang ano lang siya, paikot-ikot lang siya, no? So, ayun. Because all throughout here, the electrons or the charge are never created nor destroyed. They just move from one place to another. Okay po? So, hindi lang dapat tayo basta-basta nagsosolve. Dapat tinitingnan din natin yung circuit. Okay? Feel natin somehow ano ba yung ano ng circuit, ng flow ng circuit. Okay? Okay. Okay. Now, sometimes then, meron tayong mga circuit na nakikita na yung resistors natin naka-series. Okay? Ibig sabihin, nakakonect siya ganito, pa straight. Now, kapag ka maraming resistor, for example, meron kang R1, R2, this is R, and depende sa N. For example, yung N natin is up to 10. So, meron ka 10 resistor na nakahilera dito, naka-series. Di ba, that will be so troublesome. Nakakapagod yung ganun. Okay, so solve mo isa-isa. Now, kapag ka ganun, naka-series lang siya, pwede po nating i-connect yung mga resistor. Okay? Pag naka-series, pwede lang nating i-solve yung kanyang REQ, R equivalent niya. Wherein R equivalent is just equal to R1 plus R2 plus Rn. Okay? So, ganun lang po. So, for example, this is 1K, this is 2K, this is 3K. Di yung equivalent mo, solve mo siya as 1, magiging 6K na lang. Mas simple na yung circuit mo. Okay, so that is just a circuit. Now, pagdating naman sa voltage, of course, may kanya-kanyang voltage drop to. Okay, maliban na lang kung halimbawa in this case, same yung value ng ating resistor and then same din yung current. 'Di ba? According to Ohm's law, V is equal to IR. Same yung I, same yung R, and the same yung mga voltage drop nila. Okay, so same yung mga voltage. But sometimes, hindi sila the same. So pag hindi sila the same, meron tong V1, V2, V3. Meron siya kanya-kanyang polarity, ano? But the same naman yung polarity kasi same yung flow ng ating current. Okay? So, ang gagawin mo, yung Vs niya, corresponding voltage niya is just the sum of these. And take note, paano nga ulit yun? Pag nag-sum ka ng mga voltages, kukuha ka ng i-assume mo as positive. Say, for example, ganito, yung papasok dito, that this side is positive, ito yung negative. So, kung yun yung napili mo, lahat ng ganito, yung orientation, nandito yung positive, nandito yung negative, you'll take it as positive. So, since lahat sila the same, edi yung Vs mo is just V1 plus V2 plus V3, say for example, or Vn in this case. Okay? And again, using Ohm's law, yung Vs mo is just equal to, V1 is equal to, V is equal to IR. So, you have I, same lang naman yung I kasi series times R1. Ito na yun. Yung V2 mo is equal to I pa din times R2. And so on. Okay? And pwede mo din naman siyang, kasi same lang tong I na to na sinasabi natin, kasi series, okay? Pag series, same yung current. So, pwede mo siyang i-factor out. You are left with R1 plus R2 plus Rn, wherein sabi kanina, itong sum ng mga resistors na to, that is just your RQ. Okay? So, yung Vs mo ngayon would lead to R equivalent times I. Okay? Okay, so ang point lang sa slide na to is that yung equivalent mo ng mga resistors na nakaseries is just the sum. Okay, i-add mo lang lahat. Alright. Okay, so that is if nakaseries siya. Now, ma'am, question, what if nakaparallel siya? Just like here. Meron tayong R1, R2, Rn na nakaparallel. So, kapag ka maraming nakaparallel, say for example, 10 sila, edi ang hirap nun. Ilang node meron ka? 10 din. So, i-analyze mo siya, node by node, 10 nodes. Ang hirap. Madami. Okay? So, pagka ganun, pwede mo namang i-combine yung resistors again. Okay? Kapag ka nakaparallel siya, tingnan mo dito sa next circuit. May, pwede mong isolve yung R equivalent niya. But in this case, special na yung case. Okay? Ganito na siya paano isolve. This is just a derivation. I will just go into the conclusion na dito. So, yung 1 over R equivalent mo, again, 1 over R equivalent mo is just equal to 1 over R plus 1 over 2 plus that 1 over Rn. So, depende kung ilang R meron ka. Resistors meron ka. Okay? So, ganito lang pinakatatandaan mo. Now, say for example, meron ka lang dalawang resistor. Kapag ka may dalawang resistor ka lang, special case yan. Okay? Pag sinimplify natin yan, eto, yung R equivalent mo is just equal to R1 parallel R2, which is just equal to 1 over this one. Hindi ko na ipapakita. This is just math. Okay? Maniwala kayo. Same yan dito. If kung kayong maniwala, i-solve nyo. Okay? So, again, just remember, kapag dalawa lang yung nakaparallel, ito yung pinaka-formula natin. R equivalent is just equal to the product of the resistors over the sum. Okay? Again, kapag dalawang resistors nakaparallel, ang formula natin is the product of the resistors over the sum. Pero, remember na yung pinaka-formula niya, hindi ito. Okay? Kapag more than 3 na, ito na po yung applicable. Okay? That yung 1 over R equivalent is equal to, ganun. Isi-simplify mo pa siya. Alright? So, pagkatatlo na, so ma'am, pagtatlo yung resistors ko, so meron akong R1 times R2 times R3 divided by R1 plus R2 plus R3. No, mali. This is only applicable. Again, this is only applicable kapag ka dalawa lang yung resistor. Pag more than 2, you go back to this. Okay? Okay. Okay, so far, what are the techniques na alam natin? Okay, so going back dun sa previous natin na discuss, so pwede natin gamitin yung Ohm's law, which is V is equal to IR. Pwede tayong gumamit ng KCL, which is equal to current entering is equal to current leaving. Pwede din yung KVL, na kukunin mo lahat ng voltage na madadaanan mo sa isang loop and equate mo siya sa zero. And then, next is kapag mayroong mga series resistor, pwede mong i-combine, i-add mo lang lahat. Next, kapag may mga parallel na naka-resistor, i-parallel mo lang. Okay, ang formula, kapag dalawa lang, that is the product over the sum. Pero pag more than 2 na, pwede mo nang gamitin yung 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. Alright? Okay. Now next, meron isa pang technique na tinatawag natin na voltage division. Okay. Now, I want you to take a look at this circuit. Tingnan niyo itong circuit na to. Ma'am, putol. Okay, putol. Pero may nilagay siya na voltage. Ibig sabihin kasi nito, mayroon siyang connection pa doon, pero hindi na pinakita. Ang importante is meron kang daw V dito na voltage. Okay? Tsaka meron kang current dito na papasok, which is I. Okay? So, ganun. So, take a look at this. Meron kang voltage supply dito or may voltage potential dito. So, ibig sabihin, pwedeng mag-flow yung current papunta doon. Okay? Now, eto, pwede mo yung current na through R1 is still the same current through R2. Tama po ba? And kapag different the same yung current mo, and if different yung mga resistance value, different din tong voltage. So, na-label niya ang voltage across dito as V1, the voltage across here as V2. And then, take a look at this. 'Di ba pag nag-KVL ka, isasama po itong lahat ng mga voltage, equate mo sa zero. So somehow, itong voltage dito na source, madidistribute sa kanilang dalawa. Tama po ba? Dalawa lang sila maghahati. Para pag nag-loop ka, negative, yung value ng voltage, plus yung ilan yung nakuha niya, plus ilan din yung kanya, ay di equal siya sa zero. Okay? So basically, if you notice, sa series configuration, yung voltage supply natin madidivide lang sa mga resistors natin. Okay? Kapag ganun, meron pong isang rule na tinatawag natin na voltage division. Okay. Paano po ba yung voltage division? Ganito. So, halimbawa in this case, hindi na ako pupunta dito ha. Diretso na ako sa pinaka-formula. Now, in this case, voltage division, ganito siya. Yung V2 mo, say for example, this is V2 and you want to solve this one, that is just equal to R2, okay? Yung resistance value nung tinutukoy mong voltage over R1 plus R2, the sum of the resistors times your voltage source. Ganun lang. So in general, parang ganito lang siya. Okay? Again ha, pag naka-series, then may voltage supply, pwede mo agad-agad kunin kung ilan yung part na nakuha niyang voltage. So parang ganito, VK, K is your unknown. Halimbawa, ito yung hinahanap natin. This is VK, halimbawa lang, okay. VK is equal to RK. So yung resistor niya, okay, o resistance niya. Okay, VK is equal to RK, yung resistance niya divided by sum ng lahat ng resistance na nandun sa circuit. Kung may tatlong resistor dito, edi sum mo lahat. Okay? Basta the thing is the sum of all the resistance na nasa series times the voltage source. Okay? So, ganun lang siya. So, you have examples there sa book. You solve it. So, we have here example. I might insert clip here, video clip on this part. Next, kapag meron kang voltage division, meron din tayong tinatawag na current division. Sa current division, take a look at this. Kapag meron dalawang dalawang resistor dito, then meron kang pumasok na current dito. Say for example, alam mo tong current na to. Okay? So malamang this is your current entering, current leaving mo sa kanila, tong dalawa. Okay? So ibig sabihin yung current na papasok, madda-divide sa kanilang dalawa. Okay? Sino yung malaki yung current na makukuha? Yung may lesser resistance. Okay? Kasi mas lesser yung resistance niya, mas madaming dumadaloy sa kanya. The greater the resistance, mas maliit yung current na pwedeng dumaloy sa kanya. Okay? So, hindi pantay yung current na nakukuha nilang dalawa kapag hindi sila pantay. So, kapag ganun, Ganito ha. Again, kapag alam mo yung current na pumapasok sa isang node and given itong mga value ng resistances, agad-agad pwede na nating makuha itong I1 and I2. Okay? Using the law, using what we call the current division. Kasi yung current na to, madedivide lang sa kanilang dalawa. Okay? So, paano ba ang current division? Ganito. Again, this is only applicable kapag dalawa lang yung resistors na meron ka. Okay? Say for example, kunin natin si I2. So yung I2 natin is equal to yung pinaka-supply ng current, ito yung I, times yung R1. Kapag current division, maarte itong current division sa kabila. Resistance ng kabila. Sa voltage division kanina, times mo sa resistance niya. Okay? Ito sa current division, yung current na supply, ito times, i-multiply mo sa resistance nung isa, divided by the sum of the two. Right? Current division, maarte. Yung resistance na kukunin mo, yung i-multiply mo yung sa kabila. Sa ganito. Yung pinanggalingan ng formula na to, ito po yan sa taas. Okay? And again, this is only applicable kapag dalawa lang. Kapag more than one, ganito na po magiging itsura niya. Okay? Again, say for example, meron ka ditong I3, tatlo sila. Hanapin mo ulit sa I2. So, I2 is just equal to I, yung pinaka-supply, times 1 over RK. RK is itong R2. Okay? Yung hinahanapan mo ng current. 1 over RK divided by 1 over R1 plus 1 over R2 plus 1 over R3. Okay? So, I hope marunong kayong mag-analyze ng formula or mag-interpret ng formula rather. Alright? So, klaro po ba? We have here example na pwedeng gamitin ng ating current division. So, sabi dito, determine your Ix. Eto, determine daw natin to. Given na yung I1 is 10 milliampere. Oh my God. So, eto, given na tong current na to. 10 milliampere na yung papasok. Again, yung 10 milliampere, madedivide sa kanilang dalawa. So, meron tayong current division. So, paano yun? So, pag dalawa lang sila, this is just equal to, Ix is equal to, yung pinaka-supply, which is 100 milliampere, 100 times, maarte to, yung resistance na kukunin yung kabila, 15 ohms divided by 15 plus 30. So, ganun lang. Okay? So, I might insert video clip on this part. And that's it, guys. That concludes our lecture for this chapter, which is chapter 3, the voltage and current laws. Okay? Now, I hope klaro po. So, again, on this chapter, we talk about the concept of node, branches, and path and loop. Dapat klaro po yun sa inyo. We talk about KCL, the current entering is equal to current leaving. We talk about KVL, na kapag may loop ka, pwede mong isama up lahat ng voltages sa loop na yun and equate it to 0. Okay? Kinumbine din natin yung mga series resistor. Kapag ka naka-series resistor, edi i-add mo lang. Kapag ka naka-parallel yung mga resistor, meron tayong formula. Okay? Yung pinaka-formula is 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and that. Kapag dalawa lang yung resistor, special case. Kapag dalawa lang, that is just the product over the sum. So, R1 times R2 over R1 plus R2. Okay? We also talk about current division. Sa current division, kapag meron dalawang resistor or may mga nakaparallel na resistor, and then alam mo yung pumapasok sa kanila na current, edi pwede mo siyang diretso sa formula na current division. Okay? Meron din voltage division kapag meron resistors na naka-series. Pwede mo directly identify yung voltage na gusto mo using the voltage division. Okay? So, I hope klaro po. Please do not get tired of practicing and practicing. Na-appreciate nyo lang ito sinasabi ko dito kapag nag-solve kayo. Okay? Pagka nag-solve kayo, tapos meron kang hindi alam, parang, or meron kang nalaman na bago, doon yun na-appreciate yung mga sinasabi ko dito, na okay, ganito pala yung sinasabi ni ma'am. Okay? So, kapag nakinig kayo sa ating video lecture and somehow na-frustrate kayo kasi parang hindi nyo mag-gets, hindi kayo makarelate, normal lang yun. Okay? Na makaka-relate kayo kapag nag-solve kayo. I'm telling you. Okay? So if you have questions, just PM me. Do not be shy. Pero pag nag-PM naman kayo, wag naman yung gabing-gabi, umagang-umaga. Siguro from 8 to 11, 1 to 5, ganun. Okay? So, that's it for this video lecture. Stay safe, everyone, and have fun learning. Okay? Bye! Gamitin in solving the problem. Okay. Now, ang ano lang kasi dito sa circuit, ano, ang medyo tricky sa kanya is that, kumbaga, the thing dito is, bibigyan kayo kung ano yung kailangan nyo, ano ba yung mga kailangan nyo gamitin. And then, pagdating sa problem solving, wala talagang specific ano na if-follow mo. Like, for example, okay, una, gumawa ka ng KVL, next KCL, and then mag-OMSLO ka. Walang ganun na step. Okay? Kasi, ikaw as the problem solver, ikaw na nagsosolve, you have to, ikaw yung magde-devise nun, ikaw yung gagawa nun. But then, ang rule, ang main reason lang kung bakit nila nagde-discuss is to equip you, okay, of the things that you would need. Okay? So, tinuturuan kayo ano ba yung mga kakailanganin nyo. Pero in actual na, kayo na yung magde-decide kung ano yung gagamitin nyo. Alright? Parang ganun siya. Okay? So again, going back to KCL, Kirchhoff's, si Kirchhoff na may double F na may double H, Kirchhoff's current law, sabi lang niya, okay, na kapag ka may node, just remember na yung pag may pumapasok sa node na yun, meron ding lumalabas na current. Okay, hindi po pwedeng papasok lahat, edi sasabog yung node, 'di ba? Ironically, hindi naman pwedeng palabas lahat, edi saan galing yung mga current, 'di ba? So ganun lang, basta may it's just simple lang. Current entering is equal to current leaving. Okay? Ito. Ganun lang po yung ating KCL. Current entering is equal to current leaving.